This lesson is all about making use of logarithms to do with data that's of a non-linear form. It's not necessarily something that you would think of doing, but once I show you what it's all about, you will actually notice that there's a lot of this around at the moment to do with the presentation of data, to do with the coronavirus incident that's going on at the moment. So what we basically do is we make use of logarithms to take a non-linear set of data. So it may well be exponential data, or it may well be data, something like an x cubed or something like that. And then if we take the values and we make use of logarithms and then plot graphs to do with logarithms, we can basically take that non-linear data and transform it into a linear relationship, and then we can interpret values from our graph. So this is the very last lesson actually from the exponentials and logarithms section within the textbook, and actually this is the very last lesson for the Year 12 maths content. So once we finish this, what we will then be doing is we will be going on to the Year 13 work. Okay, so what we're going to do then, is we're going to make use of logarithms to look at some non-linear data. So data that might be, say, an exponential function or something like that. We're going to make use of logarithms or logs to transform that data, to change it, and make it into a linear relationship. Now, as it says here, they're quite often used in physics. So if you do A-level physics, you'll notice that you sometimes do plot graphs and have a logarithmic scale on them. I cut and pasted this recently because it is very relevant to what's going on at the moment. Now, this is a graph that I got off the internet. It's from a couple of months ago, but it just shows you how they have represented the data to do with the coronavirus infecting people. Now, you know very well that the coronavirus has been growing exponentially. They've been talking in the news, haven't they, a lot about this reinfection rate, which at the moment is down below 1, which means we are recovering from it. But if the reinfection rate is 2, then what that means is that everybody that has it will then reinfect 2 more people. So you see, you get that exponential growth, that it will look like something like 2 to the power x, like that. So we've got an exponential function. But if you have a look at what the graph is here, so if they plotted just those values, it would give us one of our exponential graphs like that. Okay. What they've done though, if you noticed on this graph, if they've got a log scale on this y-axis here, and then they've got the dates along the bottom. And when they've actually plotted the values with a log scale, what it's produced is this straight line here, which is a sort of, from this graph, is a prediction of what's going to happen as the virus spreads. So this is a real classic example of taking an exponential function. Instead of plotting that to make an exponential graph like this, we plot it with a logarithmic scale to produce a straight line. And what we can then do is we can look at the gradient of that straight line, and we can interpret that to do with the model. So the 2 types of functions that we're going to be looking at in this lesson, we've got either ones where we've got y equals ax to the n there. Okay, so that could be where the thing that's changing is the x here. So that might be something like y equals 2x cubed, say, something like that. Or we've got something like this, okay, where we've got an exponential function with the x in the power. So this is more like what we were looking at up to do with this one here. And we're going to look at both of those, and we're going to look at the different graphs that we can plot to transform these non-linear relationships. So you can see both of those are non-linear. Okay, we can transform those into a linear relationship and interpret the values to do with those. Okay, so what we're going to do is we're going to have a look at each of these one at a time. We're going to have a look at this one first, and then we're going to have a look at that one, and we're going to see how plotting a certain graph can transform it into a linear relationship. Okay, so what we're going to have a look at then is y equals ax to the n. Okay, so if we start with that as a relationship, okay, now that's non-linear. Okay, what we're going to do, because we're going to make use of logs, we're going to take logs of both sides. Now, do remember, when we have log with no number by it, log, remember, is the same as log to the base 10. So when we take logs of both sides, if we're not bothered so much about the base, then generally we will do log to the base 10. Okay, let's have a look at what we can do then with that. What we can do then is we can use the multiplication log law to split the right-hand side. Do make sure you're writing this down, because this is something that they do ask you to do in questions to relate your original function to the graph that you draw. Okay, so we've got log y equals log a plus log x to the n. We've then got our power law. So do you remember with logs we can bring the n down at the front? Okay, and then what we're going to do is we're going to compare that to the general form of a straight line, y equals mx plus c. Okay, now if we compare it to that, let's have a look at which bits correspond to which. Okay, so y is going to relate to log y. So on the y-axis, instead of plotting y, what we're going to actually plot is we're going to plot log y. Okay, m, which is our gradient, is represented by n. So we can go back to our original function here, and we can pick out that the gradient is going to be whatever this original power is here. X relates to log x, so instead of plotting x on the x-axis, we're going to plot log x. So we're actually, for that graph, going to have log x on the x-axis and log y on the y-axis. And then our plus c, remember what your plus c is? Your plus c is your y-intercept. Your plus c is going to be represented by log a. So if we can take our data and we can draw a graph of log y against log x, okay, now just something to say, if they say log y against log x, the first bit is always what you put on the y-axis, so y against x. If we plot that for a function of this form, then you will get a straight line, okay, approximately straight line. The gradient will be n, you can see that, where your m here relates to your n here. And your y-intercept, well, it's not y-intercept because it's a log y-axis, but your vertical intercept will be log a. So if you can read off where your graph crosses that axis, then you can work out what the value of a is, or you can see how it relates to your original function. Okay, so for a function of the form y equals ax to the n, so this is the important bit, because remember we've got two different ones we're going to look at. If it's y equals ax to the n, so the different variables that you put in are the base number here, and then to get the value of y, then what you plot is you plot log y against log x to get a straight line. Okay, right, that's our first one. So let's have a look at the second one. So this second one is going to be like an exponential growth function. So this would be like your coronavirus graph that we saw on the previous slide. Now let's do the same process that we did before. Here's our non-linear relationship, y equals ab to the x. Take logs of both sides, okay? Remember, log is log to the base 10. Log y equals log of a times bx. Use our log laws. We're going to use the multiplication law first. Log y equals log a plus log b to the x. Then we're going to use our power law and bring the x down. And then we're going to compare it. Remember, we're going to compare it to y equals mx plus c to see which things relate to which bits on that graph. So you see it's slightly different to the other one. Okay, if we have a look at what relates to what, Log y again relates to y, so that means on the vertical axis you will plot log y instead of y. This time though, m, or the gradient is actually represented by log of b. Okay. X relates to x, so for this particular type of graph, unlike the previous one where you did log y against log x, you don't for this one, you do log y against x. Okay, and then your y-intercept, or your vertical axis intercept plus c, is given by log a. So for these particular ones, again, if you need to pause this to write it down, I would say here, make sure you've got all of this copied down, including this graph at the bottom. So with this one, if you plot log y against x, you will get a straight line. There's a little watch out here, okay, because notice you don't plot log y against log x, that doesn't give you a straight line, for the reason of all of this rearranging that we've done here. Okay, so these are the bits to make sure you're sure about. You might like to highlight these. If you have something of y equals ab to the x, you plot log y against log x. So that's log y on the y-axis and x on the x-axis. Now, quite often you'll see when we do questions, when you look at questions, they will quite often say to you, fill out this table of values and plot them. So they'll hint to you whether they want log y against x or log y against log x, but they might not. So do make sure that you understand which graph you need to plot for this one, y equals ab to the x, or for the previous one, which was your y equals ax to the n. Okay, right, we've got a couple of examples to have a look at. So here's our first example. Now you will need to pause this and you will need to write that down, including a little sketch of the graph. Okay, so pause it and make sure you've got that written down. Okay, right, let's have a look at the information they've given us. Here's my equation, P equals AB to the T. So this is like your one that you had in the second example. So where the x equivalent, it's a t here, but where that is in the power, the graph we've got is log p against t. Okay, so not log p against log t. Okay, so let's have a look. This has produced a straight line. So what we want to do is we want to use this graph and use the information that we've got in the top of the question as well to work out what the values of A and B are, and then to interpret what they mean to do with this question. The graph represents the growth of a population of bacteria, so we would expect that to be exponential growth. So if we did plot P against T, we would get our exponential function graph, okay? But because we've plotted log P against T, we've got a straight line. Okay, so let's have a look at what the question is asking us for. The first part says write down an equation for the line. Now, we know the equation of a straight line looks like y equals mx plus c. Okay? Now, look at this graph here. We haven't got y on the y-axis, we've got log p. So instead of y, it's going to be log p equals, okay, mx. M is your gradient. Go back to the question. It tells you the gradient in the question. So we're going to put that in for m. Okay. X, well, x is whatever is on the x-axis. So in this particular question, it's going to be a t. And remember, plus c is your vertical axis intercept. So it's going to be plus 2. Okay. So make sure you're happy with that, where we got that equation from. It's basically down to the equation of a straight line, putting in what's on the y-axis, what the gradient is, what's on the x-axis, and then the vertical axis intercept. Okay, whoops, Poppy. Now what we're going to do is, it says using the answer to part A or otherwise. So what that means is you can do it in a different way if you want, but usually when they say use your answer to part A, that's going to be the easiest place to do it, the easiest way to do it. Okay, so we want to find the values of A and B. Well, let's take our original equation that we've been given with A and B in, and let's make it look a little bit more like the one that we got in the answer for part A. So let's take logs of both sides. So if we take logs of both sides, we get log of P equals log of A, B, T. Now, what we're going to be doing now is we're going to be doing what we did on those first couple of example slides to convert it to the equation of a straight line. Okay, so we're going to do our log laws. So log P equals, let's split this using our multiplication law, log A plus, remember because it's times together, log BT. And then let's do our power law and bring down the T. And I'm also going to write it in the order so it looks, and I can compare it with that one. So log P equals, if I bring the T down, I get log of B times by T, and then I get plus log of A. Okay, so now by comparing this with our answer to part A, we should hopefully see that this part here must be equivalent to this part here, different colour, and this part here must be equivalent to this part here. So using that is going to enable us to work out what A and B are. Okay, so let's do those. I'll do it over here so I've got an answer for room for C underneath. So log B equals 0.6 by comparing the coefficient of T. We know how to solve that now. Log B equals 0.6 using our, remember log is log to the base 10. So B is equal to 10 to the power 0.6. That's why we've been doing solving equations like this, so we can solve them in this. Pop that in your calculator. Back to the question, 3 significant figures. So, oops, sorry, 3.98 is the answer for B. Let's compare the plus C parts. We've got log of A equals 2. Okay, so remember it's base 10, so A is 10 squared, which is 100. So that gives us our answers for A and B. Okay, let's have a look at this then. Interpret the meaning of the constants A and B in the model. So what we're going to do is we're going to go back to our original function and what it looks like there. So if we think about our original function here, if I said look at that P equals AB to the T, and I said what does A mean? A is going to be the value of P when T is 0, because B to the power 0 is 1. Okay, so in the context of the question, A is the initial, is the initial size of the bacteria population. I'm going to write pop. Okay, so A is the initial size of the bacteria population. What's B? Well, again, go back to our original equation here. P equals AB to the T. Now B, okay, is the factor by which the population increases every hour. Okay, so you think as T goes up by 1, back to the question, T is hours. Okay, so B is the factor, okay, by which the population, just write pop again, my writing's awful on this, sorry, by which the population increases. Now be really specific okay, because as t goes up by 1, that is each hour. So do write that, because the examiner might be really harsh and sort of deduct your mark because you've not been specific as to by which the population increases over each period of time. Okay, so we can see from that that A is our initial value and B is a factor by which it increases each hour. So hopefully you've seen from that question how drawing a graph of log p against t, when we start with an original equation of the form p equals ab to the t, will give you a straight line, and it will enable us to then work out what the values of a and b are, much easier than drawing your exponential graph and trying to work out values from that. Okay, we've got one more example. Again, apologies, it's quite a lengthy example. Sorry, there we go. Oh, that's oh, I think that's, yeah, I think that should be above that bit, shouldn't it? Sorry, that's just been moved out. I think that's a mistake in the way around that is. Okay, so copy the question down for me then, please. In place of here should be, so in here, it's just slipped down a little bit. I moved things up and give myself a bit more room, but I've not moved that. That should be P equals A R to the N. I think it was a mistake in the book with this one. So I'll give you a moment, pause it though, all right, to just copy down the question here with the table of values. Let's have a look at what they've given us. It's about the rank and population of largest cities and district, okay, and the relationship between the rank and the population can be modelled in this particular form here, okay. All right, so this one here you can see our equivalent of x and y are p and r. So can you see we haven't got r in a power, we've got r as a base. So this is like the first one that I showed you, but can you see the question is hinting to you quite nicely that what we're going to plot is we're going to plot log r against log p. Remember with that first one we looked at, when we had r as the base, we did log of y and log of x, all right? It does tell you by drawing a table, given those values and then plotting it. So it does tell you that that's what you need to do. Okay, so if you need a bit of time to draw it down, okay, and copy down the question, then please pause it. Right, so the first thing says draw a table given the values of log r and log p to 2 decimal places. Now that's going to be nice and easy. You just need to put those into your calculator. Remember that log is log to the base 10, but there is a log button on your calculator. Okay, so make sure you can find that. It's shift and then 3 buttons below shift. That's your log. Right, so plot a table of values then. Here we go, as if by magic. I've done it here. So it's round the other way, but that was just easier for presentation purposes there. So I've got Birmingham, Leeds, Glasgow, Sheffield, Bradford. I've got the rank and I've got the population. And then I've got log of r, because that's what it told me to do. And I've got log of p to 2 decimal places. And I'm sure you can put those into your calculator yourself. So I just let you copy those down. All right, so just write those down into your book. Again, pause it if you need to. So that's your part A. Then it says, underneath this, it says, draw a graph of log r against log p. Okay, so log r against log p using the values from your table. Okay, so that then is going to be log r against log p. So for this one, okay, we're going to put our log r on the x-axis and log p on the y-axis. Okay. And it will come out like this, as if by magic. Here's one that I've done before. Okay. All right, now this, I think again, this should be a little correction of this question. I think this should say log p against log r. Again, I think that question is the wrong way round. Okay, because remember I said to you, if they say plot y against x, that's y on the vertical, x on the horizontal. So that should be log p against log r, just to get that exactly right. Okay, so we've plotted them on here. So you will need to draw this. Okay, you will need, for this particular exercise as well, you will need some squared paper. All right, so if you haven't got any at home, you can actually go onto the internet, you can find some squared paper and you can print it off on your printer, because you will need to draw some axes. If all else fails, you're just going to need to draw yourself a grid, I guess. Okay, so I've plotted it, and notice it's given me pretty much a straight line. Now, line of best fit, remember those from scatter graphs? So that's drawing a line that fits through those points, okay, as best as you can. You can see it goes through the majority of them, one or two of them a little bit off, but generally it goes through those. Okay, so that's part B there. Now part C, this is going to be similar to what we were doing before. We're going to now use our graph to work out the values of A and N. So let's do the same as what we did before. Let's start with P equals A R to the N. So I want this, okay, to look like the equation of a straight line, okay, which is like y equals mx plus c. So let's do my log bits of both sides. So log P equals log A R to the N. Remember what we do then is we use our multiplication law. Okay, we get log A plus log R to the N. Okay, and then what I'm going to do to write it in the form y equals mx plus c. Remember what we've got plotted here is we've got this as our y, so that's my y there. My x is log r, so what have I got here? I've got n times log r, okay, by using my power law plus log a. Okay, so if I compare that to the equation of the straight line for this particular graph, this is what is on the x-axis, so this is like my x. This is what is on the y-axis, so this is like my y. Okay. So if I can now work out what the gradient is, then the gradient will give me n. If I can work out what the vertical intercept is, that will give me a. Okay, so let's do the vertical intercept first. Okay, so my vertical intercept, that is your plus c. Or in my particular equation here, that's my log a, because that's my y. Let's write that underneath like we did before. Y equals mx plus c. Okay, so log a is my plus c. Read it off your graph, 6.2. That's near enough. Okay, so then I can work out what a is, and a is equal to, remember, base 10, 10 to the power 6.2. Back to my question, two significant figures. So your calculator will tell you 1600,000. So 1,600,000. Okay, right, I'm going to go up here now. Now, compare to my y equals mx plus c form, n is equal to my gradient. Now my question doesn't tell me what my gradient is like the previous one, so I'm going to need to work it out from my line. And what I can do to work it out from my line, okay, is I can find a value that the line goes through pretty well, and well, two values that I go through pretty well, and I can then use those to work out the gradient. Now let's spot some values that it goes through. Well, I reckon this one is a pretty good one here. Okay, and that is at 6.2. And another one is it does go through, it does go through this bottom one here pretty well. And because that's a plotted point, okay, here it is in my table, because it's a plotted point, we can use those values rather than reading it off. So let's work out my gradient then. change in y. All right, we know it's going to be negative. Change in y. Well, the y value, or the vertical value for this one, is 5.68 minus vertical value for this one, 6.2. So that's my change in y over change in x. Well, x goes from 0 up to, read it from the table, 0.78. So 0.78, but minus 0 if you want. Okay, and that, if you pop that in your calculator, minus 0.67 to two significant figures. Now, we don't need to unlog that or anything, because that is actually equal to n when we compare it with our original form of our equation. Okay, so these can seem quite complicated, all right, but you can see quite nicely from this question, which is an exam style question, you can see from this question that they are leading you through it nicely by telling you to table these particular values, draw this particular graph, and really the main thing you need to be able to do is being able to take your original function that you're given here and write it in the form y equals mx plus c, like that. And then reading off which bits are equivalent to the gradient. So for this one, it was n, and which bit's equivalent to the intercept. For that one, it was log a, and then looking at those particular values. Okay, right, question for you then. So exercise 14H, I've set you 5 questions there. There's 2 of these. Let's have a quick look. There's 2 that you need to draw graphs for. Okay, the others are more algebraic questions and reading values off. Please do make sure you complete these questions. It's one of those topics, because it's the last topic, you might think, oh, it doesn't matter, I'll just do the homework assignment. The homework assignment actually doesn't have any of these questions on it. It's just on the work that we've done before these. So please make sure you do complete these questions and let me know if you have any problems with them. These are not going to be submitted, all right? So what I'll do is next week I will go through the answers to these and make sure you're happy with them, but please do make sure you do them. Okay, and the other thing that I did set in the previous lesson was homework assignment 18, but just a little reminder, that needs to be completed by Thursday, 7th of May. There are quite a lot of quite long questions on it, so please don't write on the sheet, you will not have enough room. Make sure you write them out on some lined paper, and then I want you to submit those to me, please. For me, I want those submitted on Teams. Okay, right, wow, end of year 12 course, that's exciting. Okay, thank you very much for that. I hope it all made sense. If it didn't, then please do rewatch some of it.